Welcome to qnawire.
Hi, so for this problem, we're going to deal with only strong acids, and in this case, all of them are going to be monoprotic strong acids. That means that for all of this, the reaction that we're going to have is that the acid, when it goes into aqueous solution, it is going to produce the hydronium ion plus the conjugate base of the strong acid in a very quantitative way. That means that all of the acid that enters the solution, it is going to turn into hydronium ion plus the conjugate base. For example, just to give an example, in the case for HIO4, what is going to happen is that we're going to produce hydronium ion plus the iodate anion in this case. So now, in order to get the pH for the strong acid, the only thing that we need to do for cases A and B, it is going to be directly minus the logarithm of the concentration of my hydrogen ion. But for those cases, that concentration is the same as the concentration of the acid. So for A, the pH is the minus logarithm of 0.00538, which gives us 0.00538 gives us 2.27. 27. For B, the procedure it is going to be quite similar. We need to find the concentration that we're going to get. In B, we are starting with 0.31 grams of HCl in 17 liters. This implies that the concentration of HCl that we're going to get, it is going to be equal 0.31 grams divided by 17 liters, and we need to convert these grams of HCl into moles of HCl. So the molar mass in this case, it is going to be 36.5 grams of HCl per mole. And here I'm going to throw in the conversion factor that 1 mole of HCl produces 1 mole of hydronium ion. Thus the concentration of HCl, which is going to be the concentration of hydronium, will be 4.996 times 10 to the minus 4 molar. And when we plug that into our pH equation, this is going to give us a result of 3.3. Next up for C, we have 26 milliliters, which I'm going to write down as 26 times 10 to the minus 3 liters of a 7.4 molar solution of the acid. If we multiply both of these, this is going to give us the amount of H3O plus that will appear in solution. Which is 0.1924. And now, in order to get the concentration, we are told that C is diluted to a final volume of 3.2 liters. That means that the concentration of H3O plus will be that number of mole that we found divided by 3.2, which is 0.06. Using this concentration for our pH equation gives us a pH of 1.22. And finally for D, we have a mixture. So the first thing that we need to get is the amount of H3O plus that is generated and that is going to appear in our final solution. So in this case, we need to add the result from both of the components that we're adding. So the first one, we have 19 milliliters, so 19 times 10 to the minus 3 liters of a 0.00142 molar solution of HiO4, and that is added to a 55 milliliters, so 10 to the minus 3 liters of a 0.00742 molar solution of HCl. So this one comes from HiO4 and this one comes from HCl. When we find this value, we're going to get the total amount of hydronium ion. This, of course, comes from the fact that both of them are monoprotic acids and both of them are strong acids that are going to dissociate completely when they go into solution, when you add water to them. So the result is going to be 4.3508 times 10 to the minus 4 mole of H3O plus. That means that our concentration of H3O plus, it is going to be that amount of mole divided by the total volume that we have. What is going to be our total volume? Well, we simply need to add 19 plus 55. So this is going to be 74 times 10 to the minus 3 liters of solution. Again, 19 plus 55 milliliters is 74 milliliters. We turn that into liters. And we end up with a concentration of 5.88 times 10 to the minus 3. And for this one, same procedure. If we use this into our pH equation, we get a pH of 2.23. And that would be all.